Lee Norton is a consulting engineer selected to train with Al Gore on how to make effective presentations on climate change. Norton has devoted himself to presenting the scientific findings to other engineers as well as the public. Since then, Lee has taken the latest scientific research and has developed his own presentation called Climate Disruption, which he has presented to both students and professionals. He is formerly the principal of the Mitchell Partnership, which is a company that specializes in building mechanical systems and energy-efficient design. Earlier this year, Canadian Consulting Engineer magazine invited Lee to give his presentation at CCE's corporate office.
It's very unusual for an engineer to want to be an activist, as you've kind of become. So what drove you to become so passionate and to become involved in this message about global warming?
It's a long story. There's not any one event that triggered it. I did not really become environmentally conscious until around the turn of the century, around 2000. And we actually saw Maurice Strong in 2002 when it came to Hamilton. And I always remember what he said, because I didn't really even quite believe him back then, but he said life was going to get very difficult by about 2020. And he said that if George Bush gets a second term, you can take 5 years off of that. Then I saw Al Gore's An Inconvenient Truth, and that explained a lot, and you saw a lot. You saw the glaciers melting, you saw the changes, you saw the droughts. And I said, wow. I put my name in when the opportunity came along to become a presenter for the Climate Project Canada and to give...
Which is Al Gore's program.
Which is Al Gore's program, to give the inconvenient truth out to different people. And I was accepted. So I started giving it out to different people. But there were things in that inconvenient truth that weren't being answered, that I had questions about. So I started augmenting my presentations. And I just kept augmenting them until finally I'm in a situation where my presentation has really no crossover. It comes as a sequel to An Inconvenient Truth.
Right. Because you've built up, based on additional research, that everything, you're still convinced that this is happening.
Yep.
Okay, thank you.
Where we are today, Arctic sea ice, 38% down since 1979. Our carbon dioxide level is now at 386 ppm, that's parts per million. Mean sea level is 17 centimeters higher in the last century and 5 centimeters higher since '92. And the mean temperature is only 0.8 of 1 degree mean temperature increase. Carbon dioxide, that's what's been going up. During the 70s, it went up an average of 1.5 ppm per year. Since 2000, it's gone up to 2.1. So in the last 40 years, we have increased our carbon dioxide ppm by over 60. We core down into the glaciers, and we've gone back over 600,000 years in Antarctica, where the glaciers are over 5 kilometers thick. And there's air bubbles that get caught. Now those air bubbles have the exact amount of carbon dioxide, nitrogen, and oxygen at the time when they got caught into the glacier. And then we can know what the level of carbon dioxide was at the time. From 2 isotopes of oxygen and their relative amounts, we can set the temperature. Add nitrogen to that, and we can see how much sun was hitting the Earth at that time. This is what we found. The white line at the bottom, that's the temperature. And you can see it goes up and down, and you can see the different ice ages at the low point and the intermediate warm periods. And there's about a 10-degree difference between the ice age and the warm period. The blue line just above is your carbon dioxide. And you can see the two curves basically fit right into each other. Now, carbon dioxide, going back all those 650,000 years, it's gone up and down about 100 ppm difference, 180 to 280. Now, we're at 386. We are at over 100 ppm higher than the high point in 650,000 years. Now, more than that, it took, by nature, 5,000–10,000 years to do that 100 ppm, to go from 180 to 280. And we've done 60 in 40 years, We've only been burning coal for 200 years and oil for about 100 years. That's basically instantaneous. You can see we've set the safe level is 350 parts per million, and we're above it. It's because at 3 degrees is supposedly, according to the scientists, a tipping point. And we want to stay below 3 degrees. If we keep going the way we're going to be up around 550, 600 parts per million by mid-century. Right now, if we stop putting carbon dioxide into the air, it would take about 1,000 years for the levels to go down to pre-industrial times. We can push it up fast, but nature takes it out very slowly. Last year, the scientists were saying, well, some said we can let it go up to 550 and then we'll start bringing it down. Others were saying, no, it's too high, 450. Now it's 350. We have to get down below 350 because we're going to be living with this higher level for quite a while. Brown clouds caused by the pollution. They reduce sunlight, they reduce photosynthesis. They cool the oceans, and therefore there's less evaporation underneath where they cool the oceans, so there's less rain. And our climate models have shown that where they cool the oceans, the monsoon rains don't go as far north from the equator, causing the rainfall patterns to change. Smaller droplets. These brown clouds are made up of more smaller droplets because there's more particles for the water to latch onto. Smaller droplets don't drop out as even as larger droplets, so therefore in the more drier seasons, these rain clouds don't rain as much. They hold their moisture. And therefore, cooling, holding moisture, they're masking the full effect of the carbon dioxide. Aircraft vapor trails, we used to think, nothing. It wasn't until 9/11 when all the airline traffic in the United States were stopped for 3 days. And David Travis, he took measurements from 5,000 weather stations throughout the continental US. And what he looked for was the range in temperature, that is the coldest temperature at night to the hottest temperature in the day, because that stays pretty much constant in a short period. To his surprise, it increased those 3 days by 2 full degrees. As soon as the plane started flying again, it went back down to 2 degrees. It was instantaneous, it was dramatic. 2% of the total carbon dioxide now has been listed as coming from aircraft vapor trails. We're going to start looking at what's happening right now on the planet. And basically in Canada, you can see up until about the end of World War II, the number of weather-related disasters was pretty well constant. Then after World War II, it's just been increasing every year since. We're having more extreme weather. And part of the reason, or part of the systems that we want to look at is the glacier melt. 70% of our fresh water is in glaciers, and the glacial melt buffers the ecosystems, keeps the variability small. It allows the rivers to run all year. If those rivers didn't run all year, it would be back to desert and we could not grow crops. And everywhere we look in the world, it's the same thing.